So in the previous video, we have seen about discrete statistical analysis. Okay. So here we'll start up with our inferential statistics, where we'll be seeing about hypothesis testing. Okay. The other thing will be about regression, where we'll be seeing about when it comes to machine learning other aspects. So the further down with respect to inferential testing, inferential statistics, we'll be seeing that. So first thing is hypothesis testing. So what is hypothesis testing? Hypothesis testing is an act in statistics whereby an analyst tests an assumption regarding the population. So hypothesis testing is an act of statistics whereby an analyst tests an assumption regarding an population parameter. Okay, to take sample statistics in the different stage and also kind of divide and conquer. Okay. So a hypothesis testing evaluates two mutually exclusive statements. So one would be about the population to determine which the statement is best supported by the sample data. Okay. So now we'll see a few terminologies. Okay. So the first terminology is nothing but the parameter itself, which we have just seen in the hypothesis testing definition. So it is a summary description of a fixed characteristics or a measure of the target population. So I hope everyone we have already gone through a lot of parameters in our previous videos. So a parameter denotes the true value that would be obtained if a census rather than a sample were undertaken. Okay, it's not just like one particular sample; it is a whole bunch of samples. Okay, so what exactly are the parameters did we find out in our previous videos? So basically, they were nothing but mean, variance, standard deviation, and there is one more proportion. Okay, which we have not covered, but still, these are the examples for parameters. Okay. So statistics. This is another statistics is the terminology which we are using right from the beginning. So even this chapter is known as statistics itself. So it is a summary description of characteristics or measure of samples. Okay, so the sample statistics is used to estimate the estimation of the population parameter. Okay. So that is what we are going to be doing with respect to statistics and basic definition again. So example would be like sample mean, sample variance, standard deviation, okay, all sample ones. Okay. So this is not for the entire this one, but part of the population. That's why we have it as sample. Okay. So next is sampling distribution. So it is the probability distribution of a statistically obtained through a large number of samples drawn from a specific population. Okay, so we are categorizing the population in a specific based on some characteristics, and in that we are finding out the population probability distribution. Okay. So that is with respect to this one. So here you can see that we have a graph of a population distribution. Over there we have taken only one kind of examples with respect to X, and finally we are ending up with this. So this might be this smaller graph or the this graph. So it is like the portion of based on a specific population we are getting. Okay. So that is sampling of distribution of the means. Okay. And next we have standard error. Okay. So it is very similar to standard deviation. So this basically it is like for both measures are spread. Both are measures are spread. So basically standard error. The higher the number, the more spread out of the data. So the standard error or a standard deviation. So basically deviation is the mean. What we get, right? So here the mean will be something like an ideal value which we are expecting. Okay. So whatever is the deviated values are nothing but are the errors. Okay. So those are the errors. Okay. So if it is higher, obviously your standard error of statistics is higher with respect to sample data. Standard deviation uses parameters like again population data. Also you can use population data or sample data. So population data will be the entire data. Sample data will be few randomly selected data. Okay. So the standard error tells us how far our sample statistics, like the sample mean, deviation from the actual population mean. Okay. So I think now everyone is getting the difference, getting the picture of sample mean and population mean, all the difference between a sample and a population. Okay. So the larger sample size, the smaller would be standard error. Okay. So in other words, the larger our sample size, the closer our sample mean is to the actual population mean, right? So the standard error is the deviation of the means from the sample sample data to population data. And next we have null hypothesis. So basically a statement in which there is no difference or effects is expected. Okay, so if null is nothing, right? So if the null hypothesis is rejected, no changes will be made. Okay? So the word null is in context that is commonly accepted. The fact that researchers nullify. So not much to talk about this hypothesis. So it doesn't mean the statement is null itself, but rather it is null hypothesis. Okay. So next we have alternative hypothesis. So a statement in which some difference or effects are expected. So basically accepting the alternative hypothesis which will lead to changes in opinions or actions. Okay. So basically you are looking out for alternatives also. So it is just opposite to null hypothesis. So basically if you are comparing with respect to null hypothesis and alternative hypothesis, here we can just check. So a statement about a population parameter in null hypothesis is a statement that is directly contradicting the null hypothesis. So here we test the likelihood of statements being true in order to decide whether to accept or reject our alternative hypothesis. Okay, so we can use science like all this as mathematical science. So when it comes to alternative hypothesis, we determine whether or not to accept or reject this statement based on the likelihood of the null or opposite hypothesis being true. And next we have one-tailed test. So again, this is again the name itself will explain a lot over here. So basically, it is a statistical hypothesis test in which the critical area of the distribution is one-sided. Okay? So it is like one-sided towards one side. So that is the one-tailed test. So that it is either greater than or lesser than a certain value, but not both. Because you cannot be greater than or lesser than a certain value. So if the sample is being test falls into one side of the critical area, the alternative hypothesis will be accepted instead of null hypothesis, because you want to balance, right? So even if you want to get a bell curve, so at that scenario definitely you need to have it on both sides rather than on one side. So that's why alternative hypothesis will be accepted in this case instead of a null hypothesis, which does not accept any change. So here we have few examples. So basically one-tailed test, we have a few of the extra where we have the one is showing on the right tail test and one is showing on the left tail test. So basically over here it is showing the sample data as z is equal to 1.645. So that is like the rejection region. Okay. So this is little extra with respect to the curve when it comes to the opposite side. Okay. So that's why this region is called as rejection region, which is about 5% of the total. So remaining 95% is kind of symmetric itself. So if at all it is coming on the right hand side, so that is a right tail test. If it is coming on left hand side, it is called as left tail test. Next we have critical region or rejection region. So basically the critical region is the region of values that corresponds to the rejection or null hypothesis at some chosen probability level. So much to explain about it. So two-tailed test, again it is a method in which again all these test hypothesis whatever I am walking through, these are we are just going with respect to names and have a little understanding with respect to its naming itself. But technically speaking, mathematically if you are going through, you will have a lot of examples which you need to solve to understand this hypothesis better. So I think I do recommend everyone if you are very much interested walking down towards the path of the machine learning career. So definitely having a very strong base of statistics will be very helpful. So basics are the key for any job role you want to land in or any career you want to start with. Okay. So the next hypothesis will continue. So the two-tailed test, it is a method in which the critical area of the distribution is two-sided, so it will be on both sides, and test again one tail test and two-tail test, it is directly named is differentiating with respect to that, and everyone is getting an idea what exactly is happening. So basically the test whether a sample is greater than or lesser than certain range of values, so it will be on both sides. So if the sample is being tested falls on either of the critical area, the alternative hypothesis is accepted instead of the null hypothesis. Same as how we will accept alternative hypothesis in case of one-tailed test. So like I mentioned, two-tailed tests are used to determine significance at the level of around 5%, meaning that each side it will be around like 2.5%. Okay. So next we have test statistics. So test statistics is nothing but it's a measure how close the samples has come towards the null hypothesis. So basically null hypothesis means no need to change, do anything. Right? So it is like kind of the ideal result what we are doing. So it is observed that the value changes randomly from one random sample to different random sample. Okay. So that is the overall test statistics. So a test statistic contains information about the data that is relevant for deciding whether to reject the null hypothesis or not. A different hypothesis test uses different statistics based on probability model assumed in the null hypothesis. Again, with respect to learnings, we'll understand better with respect to different hypotheses taking different tests and all. So common test and their test statistics include like this over here. So basically, if you have hypothesis test, Z test, Z statistics, T test, T statistics. So again, I won't be going much in detail about this. ANOVA, that is F statistics, and chi-square test. So chi-square statistics. So similar test, we have similar statistics. So those who are interested, go ahead and solve more problems to understand what exactly all these hypothesis tests are. Okay, so basically you will be testing out these hypotheses to get better results. Ultimately, that's the goal. So when it comes to machine learning, ultimate goal is the accuracy. So now we have types of error. Again, we have two types. So there are two types of errors that is related to incorrect conclusion about the null hypothesis. So type 1 error is it occurs when a sample results lead to rejection of the null hypothesis when it is in fact true. Okay. So type 2 errors are equivalent to false positives. Okay. So basically false positive means it's like the best example what I can give you is a review. Okay, a review is positive, but it is a false positive. That means the review is negative, but our machine learning model has predicted as positive. Okay, so that is false positive. So that is type 1. And type 2, it occurs when based on sample results. So the null hypothesis is not rejected when it is in fact false. So basically, the null hypothesis doesn't reject it even though it is false. Fact is false. Okay, so that means it is false negative. Okay, they are equivalent to false negative. So basically something which is positive but it is still given as a false. So false negative. So type 1 is false positives. Type 2 errors are false negatives. So direct understandable. So here we have some kind of a table over here. So what is the reality? It can be true and false, and measured or perceived ones, true or false. So if both are true, definitely correct. If it is true and we are detecting it as false, so that is false positive. Okay, so it is false. Like we have predicted as positive. Okay, so that's why we have type 1 error. And when it comes to false, so again, if it is like false and it is been detected like true, so that is what the null hypothesis is not being rejected, and in fact it is false. So that's why that means reality it is true, but we have measured it as false. So hence this will be as type 2 errors, false negative, and finally correct. So I think this particular table will be registering into our minds very easily, right? So you have true and you have type 1, type 2. True, false in the same order. Okay, the reality on top and this one on left. Okay, so if you are putting this one on left, this type 1 and type 2 will be top. So wherever reality is, first is type 1. So you can remember in that way. So again, we have a level of significance alpha. So this is the probability of making a type 1 error. It is denoted by alpha. So alpha is maximum probability that we have in type 1 error. So usually for a 95% confidence level, the alpha is 0.05. That is nothing but 5%. Okay, of probability where it will be rejected with null hypothesis. So again, when we work on some few of the projects, we will be getting a lower accuracy, right? So we will be determining which are the false ones. So those that are we will be getting, and percentage accuracy of the false is nothing but PC, level of significance. That is alpha. And we have something known as P level. So a P level is used in hypothesis for hypothesis testing to help us to support or reject the null hypothesis. Okay, so it will tell us whether we are likely to accept it or reject it. Okay, so the P level is the evidence against null hypothesis. Okay, so basically the smaller the P level, the stronger the evidence that you should have. So that is with P level. So here you can see we have a bell curve and critical value somewhere over here. This region can be considered as the P level. Okay, if it is smaller, the stronger evidence that we should have to accept or reject based on the null hypothesis. P level is always against the null hypothesis. So that's all with respect to hypothesis testing, and we will conclude with this statistical chapter also. So in the next chapter we'll be starting with machine learnings. Okay, so we'll see basic introduction. Till now we had seen about the basic information required for machine learning. So we'll have a quick intro about about machine learning and walking down with respect to all the other learnings.